In this video, we will demonstrate how to create specifications for SecuCheck using its Java internal domain specific language fluentTQL. In order for SecuCheck to identify potential software vulnerabilities in a program, we need to provide a specification that specifies a tail flow, and the analysis will attempt to identify whether or not the tail flow exists in the source code. The specifications are written using fluentTQL, which is a domain-specific language that represents a specification logic using a fluent interface, also referred to as method chaining. Being that the language is implemented in Java, analysis writers and developers do not need to learn a new language in order to write their own fluentTQL specifications. We will now walk through the necessary steps to create a SQL injection specification with the aid of an example project that contains a SQL injection vulnerability. Our example project contains one class in which we obtained user input and use it to create SQL queries, which we execute on the database. SQL injections occur when all or part of an SQL command is constructed using external input but sufficient sanitization to remove special elements that could modify the SQL command is not performed. We find an example of this vulnerability in our demo project on line 28, where the input provided by the user isn't sanitized and is simply appended to the SQL query. To identify this vulnerability, we need to identify if data from a source method flows to a sink method. In the code, scanner.nextLine is a source method, being that we obtain data from an untrusted source, in this case user input. Statement.executeQuery is a sink method because it performs a sensitive operation, namely the execution of an SQL query. The method policyFactory.sanitize is a sanitizer that neutralizes or removes special elements that could lead to a system exploit. Using sanitizers break taint flows and can therefore help to prevent SQL injections. We will now create a new Maven project in which we will define the specification to identify the SQL injection vulnerability in the employer scheduler class. In the POM file, we add the fluentTQL dependency as well as a Maven plugin which checks the semantics of the language and ensures that a valid specification jar is created. Library methods, or standard JDK methods, for which the code is unavailable in our project, can be modeled with fluentTQL using general propagators. Such models can be reused among many projects and are not part of the queries, thus we do not cover them in this demo. We will define the specification in a new class called Sql Injection specification. The class should be annotated with fluentTQL specification class and also needs to implement the fluentTQL user interface. The next step is to define objects that store information about the sources, sanitizers, and sinks in the project. To define scanner.nextLine as a source method, we create a method object called source, and we initialize the object using the method configurator class, which accepts the method signature in the following format: class name, the method return type, the method name, and the parameters. Next, we configure the direction in which the sensitive information flows using an output declaration, which indicates that the value returned by the function should be flagged as sensitive information. We also use the return value method to indicate that the return value of the method should be tainted. We end the chain of functions with a call to the configure method. We use a similar configuration approach for the sanitizer method policyFactory.sanitize. However, we configure the method as an input declaration, given that the sensitive information goes into the method. Being that the first parameter of this method would contain the sensitive information, we use a param method with a parameter ID of 0 to specify this information. We also add an output declaration for this method, being that the return value of the function contains the sensitive information. We follow a similar declaration for the sink method. However, only an input declaration configuration is required. After declaring method objects for the source, sink, and sanitizer methods, we configure the specification query, which will identify the presence of the taint flow. We will specify the query in the getFluentTQL specification method, in which we create a taint flow query object and initialize it using the taint flow query builder class. Taint flows must start from source methods, and we therefore use the source method as the argument for the from function. If sensitive information does not go through the sanitizer, there's a possible taint flow, and we therefore use a sanitizer method as a parameter for the not through function to indicate this. The tain flow ends with a sync method, and we pass our sync method to the to function. To report an error message when a SQL injection vulnerability is detected, we use a report method. We can set where the message should be shown by using the @ method, which takes a location enum constant. The possible values are source, and the message is shown at the source method location. We also have syncs, the message is shown at the sync method location, and finally source and sync in the case that the message should be shown both at the source and sync method location. Lastly, we add the specification to an array list and return it from the getFluentTQL specification method. Now that we have defined the specification, we can compile the project and proceed to evaluate our SQL demo project. When we run the analysis, it reports a SQL injection vulnerability and provides a source and syncs for the vulnerability. Based on the result, a taint flow was found, being that a sanitizer wasn't used to sanitize the data on line 28. If we updated the code to call the cleanText function as we did on line 31, the taint flow would be broken and SecureCheck would report no vulnerabilities. These are the steps that we would follow to create a customized specification using fluentTQL. More detailed information about creating and customizing existing specifications can be found in SecureCheck's documentation on GitHub.